The idea of affordable space travel for the average person is an extremely exciting idea for many people. But exciting ideas attract a lot of media attention, with varying degrees of journalistic rigor, which can often make it hard to separate fact from fiction. If you've been following the space industry for a long time, you'll surely be aware that it's rife with broken promises and dead ends. It's easy to get pessimistic about the space news cycle. Big announcements and media hype, followed by cancellations and disappointments in the following years. But don't make the mistake of assuming that failure is a universal truth for the space industry. Every week, thousands of men and women working for public and private space organizations are discovering new knowledge, methods, and technologies that will revolutionize the cost of access to space. Companies like SpaceX and Blue Origin are planning to scale up and launch, land, and refurbish rockets at an unprecedented rate. If they succeed, they'll have a transformative effect on the space industry as a whole, lowering the cost of access to space and enabling the growth of infrastructure and economic activity in Earth orbit and beyond. But right now, this transformation is in its very early stages. In this video, you'll be learning about what the space industry actually is and how it works. You'll explore the history behind private spaceflight, the companies operating in the sector today, and the ways that space transportation could eventually get cheaper. For an industry that deals with strapping people to the front of ballistic missiles and launching them at several times the speed of sound, progress in human spaceflight has been pretty slow for the last few decades. However, technological advances, as well as NASA's strong investment in the private sector in the last decade, means that we might be on the verge of a significant acceleration in space travel, fueled by lower costs and simpler architectures. Space travel has always involved coordination between several organizations, relying on the large-scale organizational capabilities of governments, or militaries, and the engineering expertise of several smaller design bureaus or private enterprises. Since the world's spacefaring nations began deregulating the industry in the 1980s and 90s, private companies have been able to launch their own rockets, and have done so successfully and profitably. After all, there's always going to be plenty of demand to put satellites into space. But crewed spaceflight, that is, launching people into space, has always been the purview of government organizations. That might all be about to change. NASA has poured literally billions of dollars into its commercial crew development program, allocating funds to private companies to accelerate the development of crewed spacecraft. Since the retirement of the space shuttle, NASA has been dependent on the Russian Soyuz spacecraft to transport astronauts to the International Space Station. While the Soyuz is a solid, reliable craft, it makes perfect sense that NASA would prefer to launch American astronauts from American rockets on American soil. SpaceX, Boeing, Sierra Nevada, and Blue Origin have all been beneficiaries of this investment, but the bulk of funding has been put into two vehicles: Boeing's CST-100 Starliner and SpaceX's Dragon 2 capsule. Both of these spacecraft are designed to carry a handful of passengers to orbit, spend long periods of time in space, and are reusable. Their more traditional capsule-based designs make them simpler to engineer and safer to fly than the expensive and unwieldy space shuttle, and not to mention cheaper to operate. These spacecraft are purpose-built for crew transportation, while the shuttle was envisioned with multiple roles in mind, including space station assembly and satellite deployment. The shuttle was often described as a space truck, and these new craft are more like space minivans, built for transport with a little bit of cargo capability. If there are no more delays, which, if industry trends are anything to go by, is unlikely, these crafts will be taking their first flights to the International Space Station in 2018. But what's the point of having these revolutionary, cheap space minivans if there's just one place for them to go? While getting a person into orbit is costly, building somewhere for them to go is even costlier. The International Space Station itself costs an estimated $150 billion to build, including research, development, and launch costs. Part of the reason why no humans have been sent past low Earth orbit since 1973 is because all the major space agencies have been focusing on building infrastructure for low Earth orbit. Russia, for example, has been building space stations, military and civilian, since the 1970s, starting with Salyut 1 in 1971, then constructing the modular Mir from 1986 onwards, laying the technological foundations for the International Space Station, which was co-constructed with NASA, the ESA, Canada, and Japan. The research and experimentation done in low Earth orbit for the past couple decades has been essential for understanding how human bodies handle microgravity over long periods of time, and how best to mitigate its effects. But it's clear that space agencies around the world are starting to get tired of swimming around in the shallow end. The last few years have seen renewed interest in the exploration of near-Earth asteroids, Lagrange points, the outer planets, and of course, Mars. NASA's successor to the space shuttle, the Orion Crew Exploration Vehicle, is envisioned to take astronauts far further than low Earth orbit. But this doesn't mean that low Earth orbit will be ignored. As its name suggests, it is the region of space that is closest to Earth, which means that it's the ideal location to build space stations. Assembly, resupply, maintenance, and crew launches are all cheapest to this altitude. On top of that, low Earth orbit is the perfect staging area for on-orbit refueling, or the construction of large, multi-part spaceships. As Robert A. Heinlein said, once you get to Earth orbit, you're halfway to anywhere in the solar system. By privatizing the grunt work of getting stuff and people into space, and lowering costs in the meantime, space agencies will hopefully be able to focus their efforts and funding on more ambitious missions, while relying on privatized infrastructure for launch capability, crew transfer, and cargo resupply. At the same time, investment into inflatables has the potential to lower the cost of space habitats significantly. Launching these habitats in their deflated configuration decreases the volume they take up on top of a rocket, enabling more habitable volume to be launched at a time. With the advent of the reusable rocket, these habitats might eventually be launchable for a fraction of the cost they are today, which, much like the deregulation of space launches in the 1980s and 90s, has the potential to open the market up to nations, institutions, and private organizations that would not have been able to afford it before. Just like how there are an infinite number of reasons why someone might want to put a satellite in orbit today, there are countless potential practical applications for an inhabited space station. In an earlier video, I likened the future potential growth of the space industry to the rapid growth of the computer industry in the 1970s, 80s, and 90s. That's not to say I think that most people will have the opportunity to go to space in the next 2 or 3 decades. Rather, I think that many people will have the opportunity to invest in or work for a company that operates at least partially in space. Take this with a big grain of salt, because predicting the future is an impossible task. But the most likely scenario in my mind is that a more affordable way of getting to space will create a rich ecosystem of companies providing specialized services that are essential to keeping the sector functioning. Things like debris collection services, space tugs, dry docks, propellant station, station-to-station transport shuttles, just to name a few. And I haven't even mentioned the possibilities opened up by asteroid mining and automated manufacturing in space. Rather than expensively launching equipment from Earth, it's a lot more economical to harvest an entire mountain of resources at a time and process it on site. Specialized materials that would be tricky or impossible to make under a full G on Earth can be manufactured in microgravity in space. The ultra-sterile environment also allows for the creation of extremely pure materials. Some products made in space will very likely be of much higher quality than their equivalents on Earth. Obviously, this is all pretty vague and speculative, but this is the most plausible situation to me. I haven't covered all the bases, and I haven't even mentioned how this might tie into SpaceX's Mars plans. If this ends up happening, it'll happen at a slower rate than you might want, but quicker than anyone would imagine. Even today, all of these technologies are being actively developed by talented individuals. There is enormous potential for a diverse economy to emerge in space. Once it does, it'll be as commonplace as computers or airplanes or railways are to us today. So sit back, read up, and just enjoy watching it all come together. Thanks very much for watching this video. If you'd like to see more, click the subscribe button. If you feel like supporting me directly, click the link to my Patreon. And if you want to stay tuned for more updates, follow me on Twitter. In the meantime, check out some of my other videos about SpaceX and the basic principles of computer science.